Welcome back, everybody. Sorry the lighting isn't the best. I'm sitting on my back porch, so don't mind the lighting if you can't see my beautiful face. The notes are really what's important, so we're just going to go ahead and get to that. Okay, so today we are going to be talking about imaginary numbers. So don't be fooled by the name. They are a real thing. I don't know why they use the word imaginary. We're going to talk about how they're called complex numbers, and I really like using that word more, but it also explains why we have an I. So in the 1500s, an Italian mathematician invented the imaginary number, so that way we could simplify more mathematical terms. Because if you guys know, if we get a negative underneath our square root, our calculator says that it's an error. And so as a mathematician, we want to be able to go further because obviously we should be able to do something with that negative under the square root. And so we say that the square root of -1 is I, and then it opens up this whole new thing mathematically that we can do. So if we have the square root of -4, so looking at this, we can break this down to be the square root of 4 times the square root of -1. So the square root of 4, we know is 2. And then the square root of -1 is I. So the square root of -4 would be 2I. Similarly, with the square root of -25, this would be the square root of 25 times the square root of -1. And so the square root of -25 would be 5I. So now if we go to do 2I times 3I, we're going to take 2 times 3 to get 6. And then we have I times I, and that's going to give us I squared, just like when we have X times X, that gives us X squared. And then this would be using this up here, this would give us -1 times 6. And so then this would be -6. So with this one, we have a little bit more simplifying that we have to do. So remember that if we have a quantity squared, this is going to be 4I squared times -5I. So then 4I squared is going to give us -4 times -5I. So the -4 times -5 would give us 20. So this would be 20I. So again, with this, we're going to be multiplying our numbers together, and then we want to multiply our i's together just like we do our x's, and then go from there. So my graphic of the little arrows with the patterns of I did not show up, but when we have I equals, so I equals the square root of -1, we know that I squared equals -1. If we want to find out what I cubed is, this is going to be I squared times I. So that's just using our powers of, or our properties of exponents by breaking it up, because 2 to the first, or I to the first times I squared would just give us I cubed. And so then this, we know, is -1. This is just I. So then I cubed is going to be equal to -I. And then for I to the 4th, we could break this down to be I squared times I squared. Well, I squared is -1, so this would be -1 times -1. And so then this would be just a positive 1. So I to the 4th equals 1. Then if we did I to the 5th, this would be I to the fourth times I. And so then this would be I to the fourth, we know is 1, so this would be 1 times I. So I to the fifth would just be equal to I. Now, there's a few things that we could do with this. Okay, so what I actually want you guys to do is to go ahead and write these notes down. So if you need some time to write these down, you can pause it here. But if we are simplifying examples like I to the 16th, or I to the 22nd, or I to the 9th, or I to the 19th. The way that we're going to do this is if we divide by 4 and then make note of the decimal. So if whenever we divide, we don't get a decimal, there's no decimal when we divide by 4. This is just going to be 1. Then if we divide by 4 and our decimal is 0.25, this is going to be a positive I. If we get 0.5, this is going to be negative 1. If we get 0.75, this is going to be negative I. And the reason for that is these are associated to this being similar to I to the fourth. This is similar to I to the first, I to the second, and I cubed. So when we go to these, if we take 16 divided by 4, we know that 16 is divisible by 4, so this would just be 1. If we take 22 divided by 4, I get 5.5. So let's write this down. So 22 divided by 4 is going to be 5.5. So this 5 doesn't matter, but this 0.5 means that this is similar to I squared, which is then going to be negative I, or sorry, negative 1. So if we have an even, so if the degree is even, we will have one or negative 1. If our degree is odd, we will have I or negative I. So again, if we take 9 divided by 4, 9 divided by 4, we get 2.25. So then again, the 2 in front does not matter, but this 0.25 means that it's going to be similar to I, and so then this is going to be equal to I. And then if we take 19 divided by 4, this gives us 4.75. And so then this is going to be similar to I cubed, which is going to be negative I. Okay, so that is how we simplify expressions with I to a power. Anytime that we have anything else, it'll be kind of similar to these two problems up here. So again, you multiply your numbers, and then you multiply i's like you do x's, and then you simplify like what we just did. So let's go down to the examples where we are solving. So if we want to sketch a graph of x squared minus 4x plus 5. So we can put that in our graphing calculator and then look at the graph. And so if we notice, this does not cross the x-axis. So when I go to make my sketch, and again, this is just a sketch. So I have my x and y axis, and it's going to look something like this. So does it cross the x-axis? No. So will we have any real solutions to this equation? The answer is no, because it doesn't cross or touch the x-axis. So as I mentioned before, complex numbers are more like what we're going to be saying instead of imaginary numbers, but complex numbers are a plus bi, where the a is our real part, and then this bi is the imaginary part. So when we do not have real solutions, we have complex solutions. So the way that we can find those is by using the quadratic formula or completing the square. So we're going to show how we can use either one of those with this. And so we're going to solve this one by using the quadratic formula. So if you don't remember the quadratic formula, you can always sing the song. So pop goes the weasel, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully that is now stuck in your head. So again, just as a reminder, this is going to be our a, our b, and our c value. And so then for x, we get x equals negative 4, so that would just be a positive 4, plus or minus the square root of negative 4 squared minus 4 times our a value of 1 times our c value of 5, and then everything is divided by 2. Now, if we were to type this into our calculator, we would come up with a big error because we're going to have a negative underneath the square root. If instead you want to put just this without the square root into your calculator, you can do that. I'm also going to show you how we would simplify this without using a calculator at all. But again, you can use your calculator to put what I highlighted in blue in to see what's going to be underneath the square root. So this would be x equals 4 plus or minus the square root of 16 minus 20 all over 2. And so then this would give us 4 plus or minus the square root of negative 4 all over 2. As we wrote above, the square root of negative 4 is going to be 2i. So again, just highlighting that. The square root of negative 4 becomes 2i. So we take the square root of 4, and we get 2. We take the square root of negative 1, and that makes it I. So anytime that there is a negative underneath our square root, we have to have that I. Now, we can make it x equals 4 divided by 2 plus or minus 2i divided by 2. So we get x equals 2 plus or minus I. And so again, we can split this into 2 different answers. So we get x equals 2 plus I and x equals 2 minus I. And so those are our answers. Lastly, if we wanted to complete the square with something, we could do it like this. So really this should be where this equals 0 and not y. And so then we would subtract the 9. So then we get x plus 5 quantity squared equals negative 9. And then when we go to take the square root, remember the square root and the squares cancel, so we just get x plus 5. We have to have that plus or minus anytime that we take the square root of both sides. And the square root of 9 is 3. Because of the negative underneath, it has to be 3i. And so then we would subtract 5. And now because this is not 5i, we cannot combine the 3 and the 5. So this is going to be x equals negative 5 plus or minus 3i. And again, we can break this into our two answers of x equals negative 5 plus 3i and x equals negative 5 minus 3i. And so those are our answers for this problem. So be sure that you guys do the practice problems, hop on to my office hours if you guys have any questions. And also I switched to my front yard because it has a better connection to the Wi-Fi, so you do get to see my lovely face. Have a great day.